4,864. That is how many exoplanets have been discovered as of November 1st, 2021, and 60 of them are potentially habitable. By potential habitability, I imply that these planets are similar to Earth in size, have a rocky surface, and are located just at the right distance from their star. The area in which such planets are found is called the habitable zone, and you could have already heard this term, but shh, let's imagine that you didn't. The zone is just the right place for a planet to have liquid water, and water means life. In this video, we're not going to consider forms of life that could exist in methane lakes on Titan or that are based on silicon. There are 5 potentially habitable exoplanets in a radius fewer than 12 light-years from our planet, and they might contain primitive forms of life. 12 light-years are nothing in comparison with the size of our galaxy, and it's pretty possible that future robotic missions could visit these planets by the end of the 21st century. I absolutely do not care that I will be 96 years old in the year 2100. I want to see the first pictures of the exoplanets just like you. Carry on watching this video, because will be very interesting. Here is a quick question. Which star is closest to Earth apart from the Sun? I guess that you already know the answer, Alpha Centauri C or just Proxima Centauri. It is a member of the well-known Alpha Centauri system, and it is located just 4 light-years from our planet. This star is known for being a small red dwarf with a mass about 12.5% of the Sun's mass. Despite being the smallest star in the Alpha Centauri system, it has 2 confirmed exoplanets, Proxima Centauri B and Proxima Centauri C. Sadly, but only Centauri B has some potential, since Centauri C is unlikely to be habitable with temperatures of -234 degrees Celsius. It's even more pleasant to live on Uranus, where the average temperature is -197 degrees Celsius. And yes, Fahrenheit sucks. On the other hand, Proxima Centauri B is located very close to its star, completing the orbit in just 11 days. But Proxima Centauri is a small red dwarf that produces a significantly smaller amount of energy than our Sun. Therefore, the planet is orbiting the star within the habitable zone, and it's possible that it has a thin atmosphere. The mass and the radius are pretty close to our planets, so Proxima Centauri B might have primitive life forms. However, such a small distance between the planet and its star is not really good. Red dwarfs are notorious for producing flares just like our Sun, and because Proxima Centauri B is that close to its host star, such flares can be very harmful to any forms of life. Additionally, because of its tight orbit, Proxima Centauri B receives about 400 times more X-ray radiation than the Earth does. All this indicates that life on this planet must have strong protection for such a strong hazard, and probably it will have to exist underwater to stay shielded from damaging radiation. Here's a very interesting fact. Red dwarfs emit less light than the other stars, and therefore hypothetical plants on such exoplanets will have to gather all kinds of light, from infrared to ultraviolet. Thus they will be able to survive in very harsh conditions, but they will be black and not green in color. Alpha Centauri sounds like fun, but what if I tell you that there are other potentially habitable exoplanets near our planet? I mean, you could have guessed it from the name of this video, but let's have a look at Ross 128b. It's a confirmed super-Earth orbiting within the habitable zone of the red dwarf Ross 128 at a distance of about 11 light-years from Earth. By the way, here is the definition of the term super-Earth right from Wikipedia. A super-Earth is an extrasolar planet with a mass higher than Earth's but substantially below those of the solar system's ice giants, Uranus and Neptune. It means that Ross 128b is more massive than our Earth. What is more, it orbits its star in just 10 days, and therefore it's very likely to be tidally locked. It means that one side of the planet permanently faces its host star. Despite being located so close to its star, the exoplanet receives 138% of Earth's starlight, and it might be able to maintain decent temperatures. It does depend on its atmospheric composition, but scientists say that the average temperature could be somewhere between 21 and minus 70 degrees Celsius. Sounds good, doesn't it? And as I said earlier, many red dwarfs are prone to release deadly flares that can make a planet sterile. What is more, we haven't found any biosignatures in the planet's atmosphere because it has not transited its star yet. Future telescopes like the James Webb Space Telescope or Extremely Large Telescope could potentially detect chemicals such as oxygen or methane that are often created by biological processes. All we need to do right now is wait. Alright, let's leave this very interesting system and move to the next possible candidate. Gliese 1061 is also a red dwarf with a mass of only 0.12 times the mass of the Sun and located approximately 12 light years from Earth. And don't be surprised, some studies suggest that 75% of all stars in the Milky Way are red dwarfs. The Gliese system has 3 confirmed exoplanets, and all of them are super-Earths, which again means that they are more massive than our planet. Let's have a closer look at the second planet from the star, since the first one is located too close to it. As you see, its orbit is located on the edge of the habitable zone, and thus this exoplanet is warmer than Earth. The average temperature on the surface could be around 34 degrees Celsius. Gliese 1061c orbits its star in just 6.7 days, and a 6-day war that happened in 1967 could have been finished on this planet in just a year. What is more, it's very probable that this planet is tidally locked, but astronomers say that this planet might maintain a moderate climate. This is great news since the next planet, which is located in the same system, is probably tidally locked as well. Gliese 1061d is more likely to be habitable because it receives a similar amount of energy as Earth receives from the Sun. Its orbit doesn't look like a perfect circle, but the average temperature on the surface could be around minus 23 degrees Celsius if the atmosphere is similar to that of Earth. The exoplanet is larger than Earth as well, and it might maintain liquid water on the surface. However, in comparison with Proxima Centauri, the host star in this system is not a superactive that likes to produce deadly flares. Vice versa, Gliese 1061 is a non-variable star that does not produce any flares at all. Therefore, it's possible that exoplanets in this system have thin atmospheres. Seems like an interesting system to colonize. I mean, who wouldn't want to travel 12 light years of hazardous empty space to get to the planet where all plants are black and the year lasts just 13 days? This is paradise. At last, the final destination on our list, a planet that is called on Wikipedia a mini Neptune. Meet Tau Ceti F. Its host star, Tau Ceti, is quite similar to the Sun, having about 78% of its mass. What is more, it's located just 12 light years from our planet. Yes, it would take roughly 21,000 years to cover such a distance, but who cares about that? Tau Ceti F is like our Mars, but way bigger. It orbits its star at a distance similar to Mars' orbit, with an orbital period of 642 days. According to Wikipedia, and yes, I love Wikipedia, Tau Ceti F is considered the most potentially habitable exoplanet orbiting a Sun-like star. People in the Planetary Habitability Laboratory decided to depict this planet as a large snowball, and it actually makes sense. If the conditions were the same as on the Earth, Tau Ceti's F average temperature would be around minus 50 degrees Celsius. But honestly speaking, contemporary humanity is not ready to live on such large exoplanets. They require way more powerful rocket engines to leave the surface, and can you imagine living under its gravity? I mean, even Kansas sounds like a more promising place. It sounds very cool when one talks about visiting or even colonizing exoplanets, but how the hell are we supposed to get there? It takes half a year to get to Mars, one of the closest planets to Earth, and it will take the Voyagers nearly 400 centuries to cover a distance of about 2 light years. I have only 2 words to say: breakthrough Starshot. Breakthrough Starshot is an engineering project to develop a fleet of probes called starships that will reach the Alpha Centauri system. They will travel at a speed between 15 or 20% of the speed of light, and they will require 20 or 30 years to reach their destination. What is more, it will take roughly 4 years to deliver first images of the exoplanet back to Earth. They could be launched by 2036, though the first image of Proxima Centauri B we'll see probably in the year 2060. Sounds quite promising, but what about other exoplanets that are way further from Earth? Well, taking into account that there are other similar projects that are intended to get to Alpha Centauri and that technologies continue to develop, I could say that maybe the other exoplanets will also be reached by the end of the 21st or 22nd century. In any case, there is always a small possibility that probes will reach these exoplanets in our lifetime. What is more, we could even settle in these worlds. And if there are any people watching this video from any exoplanet in the universe, don't forget to subscribe to our channel. And as always, thanks for watching very interesting videos. Bye.